Okay, so now we're going to talk about the definition of torque. Torque is the quantity that produces rotation. So how are we going to define this? So let's imagine this is a top view of a door, right? So this is the hinge here, and this is the door. And let's say you want to open the door. Well, to open the door, you need to apply the force, but depending on how you apply this force, you're going to actually get the door to open or not. If you apply the force right here at the hinge, you're never going to open the door. Same if you apply the force in this direction, right? You're never going to open the door. The only way you're going to open the door is if you apply the force that has somehow a component in that direction, right? So then you're going to produce rotation. If you did that, then you can say that there is a torque applied. So there is a torque produced by this force, there is a torque produced by this force, and there is a force produced by this torque. You can see that the torque depends on the magnitude of the force and also on this distance, right? The farther you are, the higher the torque. And also depends on this angle, right? If you have a force applied on that direction, you're never going to open the door. You need to have at least some component in this direction. So we have all the ingredients to define torque. So torque is the distance times the perpendicular component. Let's think about that again. This is your door again, right? Let's say you're applying a force here, right? So what is the distance? Well, that distance is this distance here, and then you have this component here. If this is your force, this is the perpendicular component of the force, this one here. So the torque then is defined as R times F perpendicular. So here we have another example. You have a wrench and you're trying to rotate this bolt here. So how do we do that? Well, we apply the force. So now this is your R here, right? And the perpendicular component is that. So if you think about that, then you can write that the torque is equal to that R times that perpendicular component. And that is what? That is F sine phi. And this is the definition of torque. So you can see that you can break this force into two components. You have this component here and this component here. This guy here doesn't do anything for rotation. This is the only important component. And F perpendicular is equal to F sine of phi. That's one way to look at this. Another way is to look at this distance here. And that is called the moment arm of the torque, right? So that is, if you trace a line here and trace another line here, so this distance here is your moment arm. And so, and that distance, this angle and this angle are the same. So R perpendicular, the moment arm is R sine phi. So you can look at torque both ways. So this is the definition of torque. You can define torque as R perpendicular times F, or you can define torque as R F perpendicular. These are two equivalent definitions, and they both translate into this equation here, which is the same for both. So we have a question here. We have the door, and we have all these forces applied. Just take a minute to think about which one produces the highest torque or the most effective torque. All right, so as you can see, F1, right? F1 is the one that is going to produce the highest torque. This one is too close to the hinge. This one only has this component here, which is less than this. And this one doesn't do anything for opening the door. So you can have many forces applied, like in this bicycle crank here. You have the chains that are applying torque, are applying forces here, here. There is a force applied here, there is another force here, there is another force there. So each one of these forces produces a torque, and then you're going to have a net torque. In the same way you have a net force, you have a net torque, and the net torque is equal to the addition of all the torques acting on the object. An important idea is that all objects on Earth are subjected to gravity, gravitational force, and that produces a torque too, right? So where is gravity applied? The force of gravity, we're going to think that is applied at a point in the body that we call the center of gravity. So the center of gravity is that point that we can consider gravity applied to. So gravity is applied to the whole body, but we can reduce the force to just one force being applied at the center of gravity. This is a mathematical simplification that is very helpful. So for instance, here we have a flagpole, right? So there is a mass here, and the center of gravity is right there. That is where the weight is applied. So what is the torque due to this? So the mass is 3.2 kilograms. This radius, the distance from this point to the center of gravity is 1.6 meters, and this angle is 25 degrees. What is the torque? Well, we need to find the torque due to gravity here is either, well, it's R perpendicular omega or R omega perpendicular, right? So it is either this distance times this, or so this distance times this component. Both give you the same answer. So let's do the first one. So we find that this distance here is what? It's 1.6 cosine of theta. And now we multiply that by the weight, which is mg, 3.2 times g, right? mg, and this is r perpendicular, and we get the torque. The units of torque are newtons per meter, right? Because you have force times displacement, so the units of torques are newton meters. So how do we calculate the center of gravity now that we know that that's the quantity that we need? Well, imagine that you have this dumbbell here, which is two masses, M1 and M2. M1 is heavier than M2, and you want to balance this thing. So you need to find this pivot. If you find that pivot, then you can say that that is your center of gravity, right? So that's how you would find it experimentally. Mathematically, what you would do is you set a coordinate system. So this mass is at position x1, this mass 2 is at position x2, and then you would use this equation here. The center of gravity is x1 m1 for this mass, x2 m2 for this mass divided by the total mass. So that comes from finding the point that actually cancels out the torque. If you have more than one mass, then you can actually extend that formula. You have to have x1 m1 plus x2 m2 and so on divided by the total mass. And the center of gravity is it would be the position of a vector, a point in space. So it has two coordinates, right? X and Y. So you need to find coordinate X and coordinate Y.